All right, we are here in lecture 17 and we are going through the properties of polyhedra. So this is in reference to shapes A through K, which I recorded a video for you to show you what those were. Those are also in the back of your text. The book actually references these as well. And so we're going to go through and name them first. So if you go back and check out the video or the picture that I can attach for you, letter A is going to be a tetrahedron. Okay, it does appear that they are all congruent. So this is a tetrahedron. I'm also in parentheses going to put a triangular prism. Sorry, a triangle. For some reason, when the words come out, they don't always match. This is a triangular pyramid. It's just a special one where all the faces are exactly the same. So that makes it a tetrahedron. B is the one that was kind of all sorts of weird angles. And this is, we're going to call this an oblique. An oblique is the term we use when the angles are not all right. Rectangular prism. Now sometimes they call this a parallel pipette because they're all parallelograms, but we're going to leave that for now. All you need to know is that this is a rectangular prism that is oblique because the angles are not right angles. Letter C is a triangular prism. That one is right. The angles are all right angles. We're just going to list it as a triangular prism for now. D, that base is a square, and it's only got one, which makes it a pyramid. Letter E is a perfect cube. And letter F is a right rectangular prism. So I'm being a little bit more specific here because we had the one that was oblique up above there. All right, on to letter G. That base has 5 sides, so it is a pentagonal pyramid. H is one of your regular polyhedra. That is the 8-sided one, so it is the octahedron. The base on I is a square, and it has one base and an apex, so it's a pyramid. I am going to write oblique over here because this one definitely has non-right angles. When you look at that apex, it is not over the center of the base. And then J is a weird combination of things. Its 2 bases would be squares, but its lateral faces are triangles, and that does not match our description for a prism. So this is just an irregular polyhedron. Okay. And K is going to be similar because its 2 bases that are parallel to one another are rectangles, and its lateral faces are trapezoids, and that again does not fit either our prisms or our pyramids. So again, this is an irregular polyhedron. Okay, so those are our names for each of these. And remember some of the terms that we're using. Remember, oblique refers to something that doesn't have 90-degree angles, or if the apex is not over the center of the base. And regular, right means that it does, okay? And then irregular, meaning it's not a prism or a pyramid, okay? And then we're going to go down here, and we're going to run through our shapes, and we are going to say, identify which of the shapes satisfy the following. So all faces are parallelograms. This includes squares and rectangles because squares and rectangles are parallelograms with extra features. So we're looking for something that has all parallelograms. So no triangles whatsoever. And if I run through, A has triangles, B will work because it's all parallelograms. C has triangles, D has triangles, E is all squares, so we're going to keep E. F is all rectangles, so that counts. G has triangles, H has triangles, I has triangles, J has triangles, K has trapezoids. So we're going to stick with B, E, and F. A base is a pentagonal region. Now we can actually take a look up here and determine this from our names, because if the base is a pentagon, then it will be named using pentagon. So we're looking for anything that has the word pentagon in it. And in this case, the only one that has that is G. So G is going to be the only thing we list for letter B. Okay. C is a right prism. Okay. So anything that's a right prism. So we're looking for something who has two bases. Lateral faces are rectangles, and those rectangles, right? Because we want it to be right. So we want right angles. So rectangles, not parallelograms. So C would be the first one, right? That triangular prism is a right prism. I'm going to toss E in here because even though it's a cube, it's also a square prism, and it has rectangles or squares as its lateral faces, and those have right angles. So C will count. F is also going to count. That one has all right angles. And that's going to be it, because everything else is a pyramid or a special other kind of shape. All right. The last three. D, it has exactly 3 lateral edges. Okay. So A does, if you choose one of those triangles as your base, then it has 3 lateral faces and 3 lateral edges. So A counts here. B does not. B is going to have 4 because its base is a quadrilateral. C is going to count your triangular prism. There is a lateral edge where each of the 3 the lateral faces meet each other. So a lateral edge is where 2 lateral faces meet. All right, let me write that down here. 2 lateral faces meet. Okay, is a lateral edge. Okay. D, E, and F all have bases that are 4-sided, so it has 4 lateral edges. G has 5. H doesn't have lateral edges. I has 4. And J and K have more than 3. So A and C is going to be it for that. Both of the things that have bases as triangles. 4 lateral faces. We're going to skip over A and C because they had 3. But B has 4 lateral faces. D does as well, as does E and F. Okay, each of those have bases that are 4-sided. We're going to skip G has 5 and H doesn't have lateral edges, but I does. J has way more than that, but K actually does have 4 lateral faces. Those trapezoids each meet in a lateral edge. And then lastly, all the edges are congruent. So you're looking for edges are congruent. So anything that's your regular polyhedra is going to count here. So A is definitely in. And anything that has rectangles is going to be out, right? So anything that has rectangles, so B and C are out. D is out. E does, that's one of your regular ones. F has rectangles, so that's out. G is a little bit tricky. I could go either way on G, but it appears to me that the base of the triangles, the base edges, are a little bit shorter than the lateral edges. So I'm going to say that they're not congruent, not the same size. H is a regular polyhedra, so we're going to include that one. I definitely not. Those triangles are not equilateral. J, if you look at the lateral faces that are triangles, those are definitely not equilateral. And K has rectangles. So we're just going A, E, and H. So just the ones that are regular. And so those are our answers.